All right, we are to the eighth lesson. This puts us halfway through, which is fantastic. And now we are finally ready to start paying attention to veins. So I know like Mopful has written a vein. You've all interacted with veins, at least from the Gall side, and you've seen how Arvo treats them as a dispatcher, and it does this vase mode thing where it builds a vase of the vein, and then it slaps this uh, knock against or whatever to evaluate these things. But what we need to do then is, if we're going to talk about the veins and the way that they actually work, because this is where this is the real meat and potatoes of Urbit. Like Urbit as a system, all of its real functionality is buried in its veins. One of the interesting things about the event loop and vein approach is I think it's kind of it's an interesting resolution to the microkernel versus monolithic kernel debate from years ago. Um, if you go back to like 1980s programming theory, there was this divide in the community between people who thought that, okay, building a single monolithic kernel like a Unix or a Windows is a good thing, and you should just jam as many services as you can into that monolithic kernel. And all of this gets booted, and this gets into like ring zero, what parts of the system have permissions to do what territory and everything. Versus the microkernel people. The microkernel people were saying, no, what you do is you build the absolute smallest kernel you can, and then you load everything that you want the system to do as system daemons of some kind. Ultimately, while there were some experiments like Minix and others with microkernels, it didn't really catch on. None of the big companies ended up doing it. Unix wasn't it, and then when Mac went from classic Mac to Next Step platform, of course they were building on BSD Unix, and so they didn't have it. Windows went full monolithic kernel. Urbit is interesting because you do have this system split where you have a runtime, you have an event loop dispatcher, and then you have all these veins that can be modified, removed, added, whatever, at different points throughout the history of the system. And so it sort of rides the line between what would a monolithic kernel and a microservices kernel, microkernel look like when you build this. There are a lot of contingent features of veins. Obviously in the design of any particular vein, there's somewhat arbitrary decisions that had to be made to structure it a certain way. The convention of using a single letter to carry out the dispatch, and then you have alphabetically named veins, is an Arvo convention that it uses a map in the dispatch. There's nothing that's actually intrinsic to the system about that. You could definitely do something else, or permit other symbols or other lengths of symbols. It's just a map lookup in arvo.hoon, if you'll recall from that. But anyway, so we have what? We have Ames, Behn, Clay, Dill, Air, Gall, Iris, Jail, Conway. Okay, so we're at 10 veins today. This number has generally speaking grown. There were a couple of times it shrank. Ford was the build vein that got folded into Clay, and Hall was, I don't know if Hall was ever considered a vein. It was the old communications protocol that the chat stuff ran through prior to like 2019 or so. And I don't know if it was actually a vein or not, but it occupied the H space in the namespace. So, all right, so we have these veins. So we have this, we're going to use Arvo to route and control moves between veins, right? It's just Grand Central Station. And so what Arvo needs to know, the same way that the runtime needs to know what an Arvo-shaped noun is, Arvo needs to know what a vein-shaped noun is. So we need to be able to look at a vein and say, okay, what is the actual shape of the core that gives this vein nature? This is Pyro. This is for this afternoon's work, but let me just go ahead and use the same window here. We need like people are like, what can you do with AI? What you can do with AI is you can build something that will like intelligently place windows on my screen when I switch my view. How about that?
I mean, Pmux does that.
Mise en scène. Well, okay, in this one specific, very limited context, yes. And I mean, like VS Code can remember this, but like the whole screen, like with your Zoom needs, I need the chat and the participants open and stuff. Anyway, all right. So formally, we have a vein-shaped node. All right. So what that means is we have something that presents these 4 arms. So we're going to have something that handles an incoming task. We're going to have or I guess 5 arms. We're going to have a load and a stay, and those are both migration arms. So we're not going to do a lot with them. They're basically, it's like on load and on save in other cases. But it's stay instead of save. Just puts a vase is all it does. You have a take, which is going to handle a response that is coming back to you. And you're going to have a scry, which is your read-only binding at a particular path. Now, the distinctions that we kind of glossed over before about a sign, a gift, a task, and a note start to matter more. So I guess the way to set this up is, so a vein sends a note to, maybe I should actually make this a markdown file instead of a Hoon file. That'll give me better. All right. All right. So a note. So a vein sends a note to Arvo's call. Arvo sends a task to Vein's call. All right, so those look the same. Like we have call arms that handle the same way. The vein does whatever it needs to do, and then it is going to send. It's going to emit a gift back to Arvo's take arm, and then Arvo will send note to Vein's take arm. And I think I have a wrong, I think I'm wrong here. We have I'm missing a sign. What was the sign again? The sign is the final. It'll send a sign here. Yeah, I'm wrong there. All right, so these start to matter because now that you're looking at veins, you're actually seeing all 4 kinds of these things getting passed around. So you have these actual mechanics of this. So what that means is that when you send something to the call arm, it gets placed in a vein's duct. And a duct is simply, let's do this in one line. It's a list wire. So it's the causal history. It's the ordered collection of moves that represent the causal history for the value. So you're able to move things forward and backwards along this duct as you do this. Arvo doesn't know a lot about veins. We saw that previously. Let's go to Arvo sys arvo.hoon and look at one of the places we care is, all right, so this van here, you'll notice it's described here, veins while we desire it. Grub is the Arvo larval state. And so one place that it keeps it is it keeps map term trap vase. So what is this telling us that it's a map term trap vase? Like interpret that for me.
I mean, it's a map from the name to, I guess, a vase. I'm not sure what trap is.
You know what a trap is.
Do I? I always forget.
It's a bar dot.
Oh, that's right. So it's just a compiled vase.
Yeah. So it's basically, yeah, we've compiled it, but we have not evaluated.
Gotcha.
Right. Like a trap is like a hold. It's like just
Okay.
saying we're not going to do anything with it yet. And so what we've done here is we've compiled this whole set of the veins that we need. And we can provide those to larval arvo or whatever that we need, because larval arvo isn't going to go do all the work of compiling its veins and everything ahead of time. It'll deal with it after the upgrade. It needs to know about these things, but it'll deal with it after the upgrade. One of the other places that we know about veins is here's the actual dispatch. And this is the place where it actually matters that we're using the single character vein identifiers. So this is what we would change if we wanted to permit other kinds of vein interactions. Right. So that's your registry. That's all it is. And then the other thing is the actual definition of a vein. All right. Refresh my mind. What do we have here?
Isn't worm like a cache?
Yeah, so worm was our cache so that we don't have to rebuild everything every time we want to touch something in a vein. And worm will probably be moved into the runtime. They've been talking about it when the Siglus caching stuff goes live, but I imagine it'll probably be, like next spring or summer before that's a priority to do. But I imagine we'll see a pretty good speed up from that. And
why, Neil, why here do they have a vase and the worm? Isn't the worm just the cached computation? Like, why do we need a vase also?
You need so the vase it's a vase of the vein. So, it has the right shape, it has the right limbs when you need to do these lookups. But you only use so every time you do a calculation, you check the worm cache to see if that calculation, whatever part of it, is already present. And if it's not, then you have to slap and slop against the vase to do the calculation. When you have the result of that, you can put it in the worm cache. But you have to have the ability to do the raw calculation up front too.
So vase is like the the worm is the cache when you actually do a computation. The vase actually holds like the raw. How do we actually do the computations if we've not yet cached them?
Yeah.
Okay.
And this is a place where I feel like the Urbit type system is a little bit underspecified, because it would be nice to be able to say something is not only it would sort of be nice to be able to say something like this, like there's like a vase builder that guarantees that it's the right shape. Right now we don't have that, right? Like if we go into vase mode, we're just in vase mode. I mean, you can go to meta vase mode and work untyped or whatever, but you're sort of just trusting that this has the right shape. When you have it here, and obviously things will break if they don't. So for instance, when you do the actual, so like when you call something into a vein, this is what you're doing with a scry. Right, so you're getting your vein, and then you are slapping against a manual lookup of the labeled quantity of the limb scry arm. There's the limb stay arm, the limb load arm. So your vein operations are just like very explicitly into a vase that has to have a type of the right shape. This is kind of weird code. I guess, yeah. So then we're slapping the gate that we get from that, and we're pulling the buck arm out of that. Yeah. Okay. Yeah. So this is, I don't know, it might make sense actually to come back and go through the vein engine more at this point. We sort of mentioned the vein engine when we did Arvo the first time, like 3 or 4 lessons ago. But the vein agent isn't very long, right? Like it does, it defines a few operators here, and then it has some other specific handlers. Plow is basically how do I process each event request as it comes in, and work through these. And then that's it. Right? I think that's how a vein actually works at the end of the day. Everything's done in vase mode of the vase of your vein. And then you're manually calling out the specific arms that you need to result in. Kind of it's neat to work in vase mode. And I think it gives you a lot of insight into what's going on with why Hoon behaves the way that it does. Anyway, okay. So a vein, if you go back and you look at the compilation order, you talk about the upgrades, all that stuff. Veins have as their subject, they have sys Hoon, they have sys Arvo, they have sys Lol, and they have sys Zeus. So veins do see Zeus, which provides a lot of standard library utilities. Arvo needed Hoon to build itself, which makes sense. It needed part of Lol. It doesn't actually need all of Lol. So there's places where it refers to like ... part, I think is the cutoff there. So Arvo isn't compiled against all of Lol when it builds itself. Lol is important because it gives you it's shared headers. It gives you shared interface definitions for things. So it's sort of just like, your shared function prototypes for everything. Man, that Ames is a monster. Let me scroll all the way back up here. We're going to look at Ames. I think it might be the first one. We might do Clay first. I don't remember if we do Clay or Ames first. Today we're going to look at Behn and Dill, because these are far more manageable veins than Ames. Ames is just absolutely gigantic. So Lol is going to act as a header, so every vein can see the shape of other headers. Let's find. Okay. So the basic role, if you look at Behn, if you look at Clay, whatever, they have to define a gift and a task, right? This is their information. How do they communicate with each other? Some of these are standard. So all of them have a Vega, for instance, because a Vega is your notification that you've come into being.
Is that right?
Go ahead.
Is the Vega that you come into being, is that correct? I thought that's the born.
Well, Vega is like a notification to the vein itself.
Oh, okay. Okay.
It's not an invocation.
Gotcha.
Right. Born is create, and then
gotcha. Okay.
Run. Vega is notification to the vein that you are now mature, you exist. Here you go. Okay. I don't know exactly why they're necessary, but they all have Vegas, and Vegas never return gifts. So it's just sort of it's a flag.
Okay.
For the vein of why this takes place. No, but basically they define gifts and tasks. And that's everything you need. Let's see if I can turn on the let's see if I can get Hoon Assist here. Yeah, there's my Hoon Assist. Right. So all of these are ket-wutted because you just want to use them. You want opacity around like the specific values that might be entailed from their context. But you want to be able to use them as visible archetypes for everything else that's going to be interacted with them. So you're marking this as a lead core when you build this. Yeah, an opaque generator. All right, let's see. Let's look at the other two things. Let's go to the event loop engine in Arvo and look at mod. All right, so this is what actually handles the updates to a vein. So you'll recall that if you run the larval arvo through what, it will, this is, the larval arvo updates itself to its goal is to get into the new world as quickly as possible. So when you have an update, it goes through this larval stage and it kicks back into mature arvo, and it passes in a work list. And if the work list requires triggering an update to a vein, then this will come in through mod what pith in LE, which is the event loop engine. So this is where it's actually getting built here. There are a lot of clauses here that are kind of like what's an op-ed or a soul, right? The two things that I want you to particularly note here, one is us building Lol and Zeus ahead of rebuilding the veins, right? So this is just simply slap your value here, get your result out, and then down here, the send tis clause, this is what's actually doing the vein recompilation for each one of these. All right, so you're gonna, everything that needs to be recompiled, so everything in your work list that is a vein that needs to be recompiled gets passed into this role, and you're literally reading these values out of their out of their Hoon system, Hoon desk on base, and then running update and create were the ones we were looking at a second ago that were doing the slim slap algebra when we were producing those. And then you've done this. Mopful, when you built Lick, did you have to mess with any of this, or was this all automatic?
This was all automatic. You had to mess with lull and your vein, basically.
Yeah. So all you have to do then is register.
Yep. You might have
this.
to add something in arvo.hoon. I think there's like a send.
There's the
there's like a send. Yeah, right there.
There's the grow that this is just so it has a place in the dispatcher.
Yeah, I don't think you. For some reason, this wasn't like strictly necessary. It's just you couldn't use the send L with the pass card for this to work. Like it was like there's a weird. Basically, you have more than 26 ways of doing this. It's just you don't necessarily need this. This adds convenience to the pass card, is my understanding.
Because it's a wet loss.
That's true. Yeah.
Right.
Yeah.
So it'll fall back. So you could explicitly dispatch to Lick or Con.
Yes.
That's going to open up some very interesting possibilities later on.
It will, won't it?
When people start building their own custom bits and pieces for this.
Veins are unbelievably easy to write.
Well, there was someone, I mean, I think this was just the initial fervor of excitement that everyone gets when they discover Urbit for the first time. But on Urbit Dev recently, someone was, and on Twitter, someone was talking about like, so can I just like download Urbit and modify it? And everyone's like, yeah, knock yourself out. Like much easier said than done, but yeah, that's all that you have to do here to make this take place. All right. There's another place where if we so this is if we update Zeus, then this is us forcing it to rebuild all of the veins because the veins are compiled against Zeus, for instance, right? So all of these things cascade down. We don't have to like this is how Arvo knows what needs to be triggered in the order of things. So Arvo knows that if Hoon is changed, it has to update Hoon before it can update Arvo. But if Zeus is changed, it knows it has to update the veins, but it doesn't have to update Lowell. So this is what's taking place in Adorn, is it's dealing with this cascade down of how do I rebuild Lowell, how do I rebuild Zeus, how do I rebuild veins as I move down through what points I triggered here in my update. All right. Vein wise, we previously had talked about there being, let me find my whole list of veins here. That'll work. Okay. All right. So when we were talking about the runtime, we talked a little bit about IO and that there are IO drivers that we're going to have to take a look at. And originally I was going to do all these separately after we talked about the veins, but I decided to just roll it into the veins. So we will talk about these some today. But of these veins, right, Ames has to do communications, so it needs IO. Behn has to know the system clock, so it needs to do IO with the host OS at least to find that out. Clayla's file system stuff obviously has to do a lot of IO. Terminal driver, IO. Air and Iris HTTP, IO. Gall is landlocked. It doesn't need to do any IO. Right? Like everything that Gall does is mediated through some other part of the system. You're typing into Gall, it's coming through Dill, and then entering the application vein. So Gall is very interesting when we get to Gall in a few weeks, because it's actually, if you think about an agent as being a noun of a certain shape, it has a certain number of enumerable arms, and you're slamming it with the sample every time you build it. Like Gall is actually kind of simple. Because of scribes and other things, it's not as simple as it could be. But like if you wanted to write a Gall, which I'll probably have us do, like write a very minimalist Gall for that exercise, it's really simple because it doesn't have IO. Like it doesn't have to worry about that. Jail, likewise, it has to do a lot of things to make sure that your crypto and your security is correct, but it doesn't have any IO. If it needs to know the state of azimuth, it asks something else to find out the state of azimuth. If it needs to do something with someone's public key, it asks something else to go get that public key, and then jail just does the calculations on it. And then Con and Lick are sort of explicitly IO veins, so they're, that's what they're doing, one way or the other. But okay, so we're going to start with Behn because it really is the simplest vein. It's almost the simplest possible vein. We're going to go ahead and write like what would an empty vein look like, so we'll introduce one this time in the exercises. It's just like here's a simple vein, which is kind of fun to do, but you don't really need to do much with it. Okay, yeah, I don't know what happened there.
Yeah,
all right,
okay. Sorry about that.
Okay, let me go to Behn here. All right, so we're going to start with Behn. All right, so it's a timer and it's a wake-up call system. That's all it does. So if we want to run something in Behn, all right, so we can give it some .ket. So like here I have this .ket scry, and it's going to it's going to do an X scry into Behn of hour, nothing, time at debug timers. So it's looking at what debug timers are available for us there. It's going to return it as a list of times and ducks. So this is basically like what are all the times that have been set to check and wake up on things. So it's currently 10:34, or so I guess 15:34 GMT. And so in a minute, Ames is going to wake up and it's going to check some things, just to check and see whatever, are there kids updates, are there, whatever's going on with everything, that all the ships that are upstream from me. And you'll notice it's checking Sogripe Dister, Dister Dazod, Mr. Dister Dazod. These are the like groups and talk upstreams here. This is a fake SOD, so it's not going to be doing anything with this, but in principle, it's trying to check and look these things. There's a HARC system hook. Check and see if I have any HARC notifications. It looks like that's probably taking place on a 10-minute delay. This one probably this HARC check actually in the HARC clear. That's a garbage collector, maybe. I don't know what that is. Anyway, so these are just all the events that are sitting in this queue for Behn. If we look at Gen timers, I think is the so this is doing basically an unwrapped version of what I was looking at there, and then it converts it into a tang, so you get a kind of a nicer picture out of it. So let's see, less timers. Actually, it ends up looking exactly the same. So the pretty printer is doing the same thing that the formatted tang is taking care of here in this case. Anyway, all right. So every time we look at this, we're going to be interested in what is our actual interface, and this is essentially defined in LOL. So if I scroll over a little, a task is a request to Behn, so it's kind of a better place to start to figure out what it does. So I can cancel an alarm, so that's a rest. I can do a drip and a huck thing. We'll take a look at those a little bit later on. These are vein management operations here. I can set an alarm, and then I can have an activate that comes from something. And then in response to things, I can set, do I want to trigger a subsequent alarm, other kinds of things. And then most of the time, Behn is going to return awake. So typically with Behn, you're going to send it await, and you'll notice you're sending it an absolute time, not a relative time. Right? So you're telling it when you want it to wake up, not wake up in 5 minutes. You have to do that yourself. Actually, there's a thread we should take a look at real quick too in that regard, which might be time. Yeah, so get time strand IO, sleep, get time strand IO. So this one is just hanging for a certain amount of time until it gets this result back. And we say, okay, what's going on with strand IO library? All right, so now it's waiting until it does a take wake. All right, yeah, so it's just waiting for Behn to actually send this value back to me. A send wait is telling Behn to wait until whatever time it has been set to do. So Behn is really straightforward. There's not a lot to it. It's a stopwatch. So you're going to send a wait, you're going to receive a wake. Most of these other things are plumbing to make sure that it can do the right thing in certain upgrade cases and these kinds of things. The other weird one is a drip right here. A drip is actually a way of if you're getting something back from let's say the example in the notes I think is Clay gives an app. Clay wants to return a value to an app. It wants to give a gift to an app. If the app crashes, then when Clay sends the gift back, if you didn't have the ability to pass through Behn, you could also trigger a crash in clay, is what would happen. And so what a drip does is clay passes a drip task, wrapping the gift, which is the vase, to Behn, and then Behn sets a timer to pass it to the vein or to the agent. And by doing this redirection, you can isolate clay or Ames or whatever from the crash. So you basically get this buffer against a crash, because I guess Behn can handle this more gracefully than clay and Ames in the big veins would do in that case. So a drip is basically a buffer. It's saying someone else needs to send information, so they send it to Behn and say on a timer, then pass it forward. Okay. Yeah. So then a wake, and then if error is null, then you're fine. If error is something, then it's failed. So that's where the drip stuff comes in. Okay, let's look at Behn, cis-Behn, Behn. Okay. Every simple vein is going to have the same structure. There's going to be 3 primary cores that are going to be cons together to build this. There's going to be a type definition core, your header at the top. There's going to be a helper core, and then there's going to be the primary vein interface. It's a good simple pattern. You're going to see it in Behn. You're going to see it in Dill. You're going to see it in Gall. You're not going to see it in Ames, because Ames is a giant. I mean, for comparison, Behn is a little over 300 lines of code. Ames is 5,000 lines. Clay is something similar. Yeah, Clay is 6,500 lines. So yeah. All right. Okay, so let's start with our state. Same way we would with the Gall agent. Okay, so what does Behn actually know? All right. So it only has 2 kinds of notes that it expects to receive. It expects to receive weights or flogs, which are flogs are debug printfs. So that's probably just a delayed log ability that you could send that forward. So those are the notes that it expects to deal with, and the signs it expects to deal with are sending a wake or a wake with a gift. So this is your drip case. So you're either just sending a wake back along your wire, or you're sending a wake with a gift because there's a drip wake up that needs to take place. Behn needs to track a set of timers. I don't know if there's value in this being a tree versus being yeah, it's probably for efficiency here. All right, so cast your mind back. Tree is this archetypal value in Hoon where it's a ternary tree. So it has a value at the node, and it has a left tree and a right tree, which themselves can just be a value. So, if you had 3 values, you would have N, L, and R would be where the 3 values would end up. But this can cascade down. Tree is the primitive that you build a set or a map out of. But the difference is a set or a map has a validation rule. Sets and maps order their values based on a hash of their keys, or a hash of the value in the case of a set, hash of the key for a map, hash of the value for the set. This means that they give you nice properties in the lookup speed that you have with them, for instance, because if you take the hash, I think it's actually the hash of the hash for the key of a map, then there's a 50% chance that it's going to be greater than or less than the value that you're currently at in your tree. And so what this does is this naturally balances the tree. Here, Behn state is just defining a tree, and it's just passing in the key as the value that's going to get built into this tree. So it looks like Behn is optimizing on not doing any validation. This is apt in and apt by are doing that for a set and a map, but it is not optimizing on balancing the tree. Since in my experience, there don't seem to be a ton of Behn timers on any given ship, typically. That's probably the reason that they're doing this trade-off. Like, it's just not a big enough tree for us to worry about. Can we, do we need to optimize this tree? Unix duct is going to be the value that, where you're getting these Arvo is going to receive wake up notifications from the runtime. It's going to put them in the Unix duct. This is how it's going to know to do things. It's going to track next wakes, and then it has its own drip stuff to deal with drips. Yes. Okay. Those are, I think, fairly straightforward there. All right. Then the next one is your nested core pattern. All right. Anywhere you see a bet, you are in the nested core pattern. Rabsef, I believe, was the person who started calling these engines the abet engine. It's not favored by the kernel developers because there are things that we call engines like the Behn engine in Arvo that do not use the abet pattern. But I think it's like I like the snappiness of calling this the abet engine. So yeah, and the map engine, right? So there are things we call engines that are built on doors that are a little more general than what we're talking about if we're doing this sort of thing. But if I call it an engine, that's because it's a sticky name. Maybe we need some other term for it that's like engine that captures it better. But calling it the nested core pattern is also like a really awkward term for this. All right. Okay. So if you haven't worked with these before, we're going to start running into them in the veins because several veins are built on this pattern. But the basic concept of a nested core pattern with an abet is you have an outer core which builds a list of cards and state changes. Then it produces the queued changes all at once with the abet call after producing all of these things. I sort of think every time I use one of these, the analogy that suggests itself to me is it's sort of like we're cranking up like a wind-up car or something, and then when you abet, you're just letting go. You're just letting the thing run. There are two major patterns of nested core in the veins. Behn represents the simpler one of these, and then you'll also see more complicated ones in. I think Ames is probably the main offender in being like a really complicated one. And so what you start to see there is these prefix name ones, because you have several outer cores and you have to keep track of which one you're in. So you prefix the ARM names this way. But for Behn, this is all it needs to be able to do. There are a number of semi-standard names in these that you'll run into. Emit conventionally adds a move to your current list of moves. You'll notice that it prepends. This becomes significant, as sometimes you'll discover carefully, which is that when abet, which is so emit adds a move and nil adds a list of moves. Abet returns all the changes in moves in state, which is what it's doing here. But conventionally, abet is going to flop everything. So it's going to swap your order of your moves so they resolve in opposite order. So the moves that you are prepending at the end, the moves that you're prepending will be evaluated after the moves that you've already added into your queue. This does matter if you are issuing moves that need to take place in a certain order. And it gets down to the way that Arvo is going to handle move processing. Now, typically, so if you're on a local system and you're generating a list of cards or moves, the system will evaluate them in the order that you produce them to the kernel. But if you're doing it over the network, things can get out of order on the network. And so if you're doing this to a ship that's remote to you, you may run into issues if you need card order to be structured a certain way. But here, we're assuming we're doing all this local. So there's some management around it, but we have to take care of it. All right, there's an abet. So there's a take drip that'll handle when you actually get the drip and produce all those. Awake. Okay. All right, so this is the pattern. The way that you're going to use the pattern is if you come down to line 210, we start the main core. All right, so this is Behn itself as a vein in the same sense that we build an agent. Here, yes, we have our ducks and everything. Okay, so we have a load, we have a stay, which are our migration arms. We have a scry arm. Scry arm has our manual handlers. I'm looking for our take arm. Okay, so here's our take arm. So take is going to receive these values from Arvo and then figure out what to do with them. Like, how do we actually pass these things forward? When it calls the engine pattern, here's what actually takes place. It's commonly associated with the Tizket to grab a list of cards or moves or whatever. But you're going to have an inner event. Sometimes this is an abet or something, and then you call other values on it. And you're going to operate on your helper core. In this case, it's called your event core in Behn, but that's not universal. You're going to operate on that, in this case, through take drip. And then what that is going to produce is a core that then you're going to call a bet on, and that a bet is going to produce your list of moves and your state changes. And then you're going to return that out of the arm that contains that value. So it's kind of a thick, it almost ends up feeling more like go-tos and spaghetti code when you build these. I've built code that uses this a few times, and I'm not a huge fan of the pattern, but here it is. It's the way that these things get written, so may as well get used to doing this. One of the nice things about the event core, though, is that the event core can be stateful. Going back here to, yeah. So our event core can be stateful because we can pass it. Sometimes in this case, it's a gate, but we can do it as a sample or as a door with a sample too. So we can pass it in these bits of state, and so it can keep track of these things as it builds up its list of moves or what have you as it produces these. All right, so we'll mess with those. Yeah, so basically that take comes in at take drip and produces a card, give meta drip, and then produces a duct card, which is a this, right? So this is going to refer to the core that we are currently in. In this case, it's a dot. If it were a door, it'd be done with a lustar. And then that comes back. So that's just the value, but then we're going to call a bet on that. So a bet is then evaluated against the result of that take drip in that case, and produces all these particular values here. The other one to look at is, let's see where the wake is handled. Yeah, so wake just Yeah, wake just manually modifies your state with, there's another wake, right? There's another piece there. Wait then routes through set timer. So it produces a timer, and then you modify your state in this, which is the working core that you're in. Yeah, this is the event core. And then once you have that, you're able to pass that forward. So let's also look at where the wait comes in, because this is the original request. Actually, that's it. It goes right in here and then runs into set timer and then comes out. Yeah, so this is really simple. Set a timer, maintaining order. So it just puts it in the map and with the duct and hangs onto it until it gets a wake call from the runtime. Yep, not a yeah. I mean, it's a simple vein, ultimately. Now, let's see. Let me add.
Before we move on, Neil, I have a quick question. Which is like, where does this interface then where does like the rubber hit the road with like actually interfacing with Unix here?
That's
Because
where we're going next.
Okay, perfect.
But I need to open. My var repo. So one moment while I grab that. I think too much open in my life here. Let's see. All right, let's see. So there's. Oh, sorry, that is the repo. I need to open there, not Arvo. We have too many repos. Also, I have like 10,000 files in my Urbit directory. Sorry, I was trying to figure out how to add that, but it's being a pill for me. So I'm just going to open the file directly. So we're going to go to var io Behn. Their package, their IO Behn. All right. So this is your IO driver. What's actually going to happen is in var auto.c, which I should also open here. In var auto.c, there's a place where it registers, here at the end. What it does is you have functions that handle particular tasks for you, like U3 Behn IO init. This is the main handler for how we initialize things. What we're doing here with AutoLink is we're registering a callback in the CARU like global set of pointers. So every IO driver that you have has to be explicitly registered here. So anytime you do an IO invocation from the runtime, it's going to dispatch it into CARU, and then CARU is going to figure out like where does this thing actually go? Like where does this value come from?
It round robins, which is important to note. So a card that you dispatch to var will hit every vein, and the vein goes, is this mine? Is this mine? Is this mine? And then it'll poop out if it's not. So if I send a lick card, all those different drivers will see it.
Would you call that a round robin though?
Yeah, round robins to each one. It goes, I guess. I don't know. That's what Joe explained it. That's what Joe called it.
I mean, round robin would imply that you could enter at any point in the sequence and then it would loop back.
Well, I mean, it's a linked list, so CARU is a linked list of
I guess
cars.
you could.
So yeah, you can only enter in one place, but yeah.
But yeah, okay. So everyone sees it, and then when you actually have a handler, okay, that's interesting. I didn't actually know that it passed through. I thought it just did a dispatch.
No, when you look at the talk, I think is the card. You'll see that
This
it,
stuff. Yeah, this is
yeah,
this.
yeah.
Yeah, these are the IO callback
yeah,
stuff.
you'll
yeah.
see that you check for the wire on each one.
Okay.
Um,
If talk is mentioned elsewhere in here. Auto talk, start all drivers. Okay, so that's what it's doing in this while loop. Is it's hitting everyone. Okay, interesting. All right, that works. That works for me. So you'll notice a couple things. One is that not all of these have names corresponding to veins. So there's not a one-to-one correspondence of the communicating veins to the IO drivers. So it can end up in different places. In general, it's probably a good pattern to do it, unless you were building something really gigantic like clay. But yeah.
don't do the
Alright.
con thing.
What's that?
Don't do the con thing when you name con and con.c and con.
It's so clever, but yes, it introduces a lot of ambiguity. The one that messes me up is the con messes me up because it's spelled this way, but because I did a lot of research on Rand Corporation, which has Herman Kahn. He's the guy that Dr. Strangelove is based on.
Mm-hmm.
So I'm always trying to write it this way,
Oh gosh.
which is bad because it's not correct. Anyway, so there's our registration. When we actually come in U3 Behn, a timer is set in does. Yeah, so here's does. It does calculations, checks, gets the value of the input target time. And then what it's going to do is it's going to set it using UV timer start in libuv. So you remember libuv was our main event loop handler. So we are just telling libuv to issue back, to set a callback at this time to Behn time CD. So we're telling it this is where our callback is going to come from, or going to come in. So when libuv, which is just the event loop handler, hits that time, then it is going to hit this callback function, Behn times CV, and this is going to this manually builds an ovum with U3 ovum in it, injects it using U3 auto plan, and then subscribes to the result of it with U3 auto pair. So this goes directly into Behn's call arm as a wake. Yeah, CAD there is built from C3 wake. We're telling it to go into Behn with, like, the wire is just Behn. Like there's no other info for it. These are tuple builders, shorthand tuple builders. So yeah, we're just building the manual piece and doing an arbitrary injection straight into the system for that. So Arvo sees that and it goes straight into Behn. Does that answer your question, Sidnheim?
I think so. There's something about this that's a little bit confusing to me, which is, I guess, maybe how this interacts with the event log, or how that all works. Like, is this recorded so that if you shut down, I mean, I guess it must be, because if you shut down your ship before the timer goes off, I wonder how that all sort of interacts there.
So that's an interesting one, right?
Yeah.
So Behn does not guarantee that a wake happens at a certain time. It guarantees that a wake happens after a certain time. So you can have a queue of wakes that are already, have already been triggered by libuv. sitting here, and they'll get processed when you start your ship back up.
And so then, like, yeah, exactly. And another piece about this I was wondering, I think is answered by that behavior or that guarantee, is that like these like the event loop won't be processed in such a way that it'll like always hit when a Behn timer goes off, right? Like it could be that you're a little bit off in terms of like when it goes off. I don't know what level of precision it would guarantee generally, but your event loop won't always be like synchronized with like when Behn timers will be invoked. But so since it only guarantees afterwards, that makes sense because it'll just be like, okay, the timer went off, and then after that, the next event loop process that happens, it'll trigger it or something like that. And
Yeah, see, I mean, like here I'm running it, and I'm getting my actual time, my actual lapse time is 1 plus, convert that into base 64 of a second. But there's variation, right? Like, oh, that one was almost
really
perfect.
close. Yeah.
Right, but I'm never going to get 0 because there is. Oh well, there
you
we
go.
Great timing.
But so that was like what? You ran it like 10 times or something. So 1 in 10 maybe, and maybe that was even a fluke. So who knows? But yeah, interesting.
There's also somewhere in the runtime, or maybe it's in or maybe it's in Arvo. There's a note to the effect that there's some part of the system that we would like to timestamp better, but we don't actually have reliable enough timestamps.
Mm-hmm.
I don't remember where this comment is, but there's a comment there that and I think what they do is they actually add a little bit of randomness to the timestamp value, because you can end up with the same timestamp for 2 events, and so it like messes up the wires. I don't remember where that is now, but there's a spot where that's called out as like, this is a thing we would like to fix. I mean, this is, if you go back to Behn, I mean, it's just running like
just simple Unix calls.
Just a simple, whatever the Unix. It's just give me the references, because I'd actually have to go find the dev library that has it from. Yeah, I mean, this is the problem too, is like everything's so buried in header files. We'll see, but yeah, that's all that's going on.
So I think I have a general understanding now for like how the Urbit piece, how that's all sort of like managed, how like Behn has its own sort of management for like, okay, here are my live timers, here are these things called drips and so forth, and I have all these things I'm managing, and using the nested core pattern to set that up, and also the bear part of it, which is like, how do I actually on Unix manage this in the event loop? But like, and this may have been the piece that you went over earlier, but how does like Behn from within Hoon call some of this stuff that's in Bear, or like say like, okay, please in the runtime, or like, I want to set this timer, and Behn is responsible for doing that, but like, how exactly does it do that? How does it like invoke some of these things? Does my question make sense?
Yeah, so you're basically so you're saying how Unix talks to Ver talks to Arvo is clear, but how Arvo is signaling this back out is unclear.
Yeah, like the specific, like, I have Arvo that's running, it's all this Hoon build, and then that's running on top of Bear, but like where exactly like the injection for, okay, do this, because I remember like when I was reading the docs a long time ago, and you hit on this a little bit earlier in one of the earlier lessons, was like the Unix card being something that like would specifically signal that like do a Unix thing here. But it doesn't sound like that's really used anymore. So I'm just wondering, like,
we don't have a lot of that.
Yeah, like how does Behn like specifically signal to Bear to do something that like only the Unix layer can do?
Well, let's see if we can
send out a card.
What's that?
It emits an effect, right? Like that's the GIFs and all that stuff in the lull. It just emits it.
You're talking
then-
about
So the tasks there.
the doze. It emits a doze.
Yeah, sorry, the gifts there.
Or
I always get the gifts and the tasks and stuff, but those cards, Ver takes those cards and round robins it to every driver,
I see. Okay.
right? So every effect that happens.
So whenever a vein emits an effect, like Bear will just like hit those on all the various like callback drivers and see which one of those accepts it
Yes.
and handles it. Okay,
Yes.
that makes sense. Okay.
Sorry, Neil.
yeah, I think Vane. I thought Arvo actually had an explicit handler for Bane somewhere too, but I think I'm misremembering. I mean, Bane is like, it's really simple, but it's also really fundamental because we have to get the ordered quantities correct. And one of the interesting things is that now actually has nothing to do with Bane. Right. So our actual, like, Bane is our timer, but when we actually want time, it's just the value at an arbitrary axis in Arvo that it gets directly from there. All right. Well, if you think that Bane is a little bit clearer now, let's scramble all of that by taking a look at Dill, which is not terrible, but it is more complicated. Oh, I'm in the wrong. Dill. All right. Dill has a lot more going on. It's a little more representative in that regard. Okay. All right. So Dill is described as Urbit's terminal driver. And we can pass it, direct messages, like I can pass it a text and it knows how to unpack this thing. Okay, so Dill as a vein is responsible for constructing terminal sessions and coordinating input and output, so keystrokes and everything. But most of your terminal stack is actually user space. This is Hood and Helm, and we'll talk about in Drum, and we'll talk about those in a minute too. But for a minute, we have to think like, okay, so what do we mean when we talk about terminal? Like if Dill is a terminal driver, what is a terminal? So originally, computers were programmed directly by moving wires or or putting cards in or whatever. And then you started to actually get CRT computer terminals that had a resolution that was to which they had a hard-coded ROM-based character, raster set of bitmaps that they could produce in this grid. And so when we refer to a terminal, what we mean is we have a terminal emulator, which presents like a terminal-like text user interface that we can treat as if it were an actual character display. And because it's character-oriented, we typically cannot do drawing and everything in a terminal emulator. So a terminal emulator needs to track information like your dimensions in X and Y. It needs to track content layout. Needs to track active sessions or even if you're using screen or tmux, like disconnected sessions, connections. It needs to track cursor position. It's going to provide things for you like escape code, so you can do colors and a color space. It's going to provide layout libraries, scrolling, back scroll, like does your terminal session support this? So Dill has to manage interfacing with systems that expect this kind of information. And it also has to manage input coming from a session like that. So keystrokes, ultimately. And we actually also have the interesting case that you can run Urbit in a daemon mode, which means that you may not actually have Dill connected to a terminal session at all. Due to limitations in terminal emulators, you also only have proper Dill in WebTerm. So WebTerm sucks in some ways because it's a little bit clunky. Like it could definitely do with some upgrades as far as like, mouse selection and these kinds of things go on. But you can actually do multiple active Dill sessions in a WebTerm that you cannot do in a text terminal emulator like I have down here. All right, so let's look at LOL. It's more complicated. There's other things going on, like the ability to like pack and meld comes through Dill here. There's like a whole system of logging that you can know about. The main values that you're going to need to know are blitz and belts. So belts are input, blitz are output, more or less. So belts are the tasks that you're going to receive to process things. Let's see if I can find, where's my, this might just be falling. Oh, it's falling through to belt here. Yeah, through session task. So it's going to receive tasks that are belts. So these are keystrokes, more or less. And, or, resizing your terminal results in a belt, for instance, telling you, or moving your cursor results in a belt. And then a blit is going to be an output event. Clear the screen, put a character, move the cursor from Urbit side, whatever you have there. There's a lot of other things going on here, but those are your main ones that we're going to have to deal with. Blitz give you a lot of different options here for things that we would call blitz. And since you'll run into these sooner or later, it's worth seeing them. The important ones are clear, color. More is a set of blitz, so you have to deal with it. Put is how it actually outputs text at the cursor as opposed to somewhere else. So if you want to put text in a particular place, you have to set the cursor with hop, and then you put the text with it. I've never actually seen URL used, so I'm not exactly sure what it does. And then a belt coming back is sorry, I'm looking for the keystroke stuff, but I think that may all be wrapped and then in the yeah, that must all be wrapped in the Dill file. Oh no, here it is. It's in bolt inside of belt. This is what I'm looking for. So these are your actual keystrokes. So a keystroke can be a modifier with a key. You'll notice that it only does one of control, meta, and hyper, not sets of them. If you've never looked at it before, look up the Space Cadet keyboard. Let me show you this to you real quick, because this gets into theory of keystrokes. Let me share. Yeah, so this was one that has a control, a meta, a super, a hyper, a top, and a Greek, and a shift. And it can handle combinations of these. What's that?
The Roman numerals on the side.
Yeah. Right. This is wild. That you could do all these operations on it, but the Greek characters were on the front, so you could also see what those were. Then it has all these like mathematical operations, and it looks like it does not actually have APL, but anyway, my point here is actually that you can do pretty sophisticated input modes with keyboards, and we're kind of impoverished in contemporary keyboards with just our Control and our Alt and our Shift. But anyway, maybe someday we'll be able to do more with that in Urbit. So like right now, actually, Urbit would not be able to handle Control Alt. Right. So right now it can only take one modifier at a time. So it looks like it would not be able to handle Control Alt Delete, for instance, when you do this. But anyway, so these are belts are blitz are your output, belts are your input. Hey Ted, how you doing?
Hi, doing well.
We just looked through Behn, and now we're getting into Dill here.
Sounds good.
Let me grab over to Dill, and Dill's main structure is an axle. And then there's a bunch of other pieces inside of it here, but this is sort of your meta level of, you know, what sessions am I aware of? How have I organized these? How they kept track of all these. So this is the state that Dill is going to keep track of. You'll notice Dill has the same structure as Behn. It's relatively simple in that it has your type definitions and a couple of cores, and it has a helper, and it'll have an engine, you know, and a bet pattern nested core in the helper core, and then it'll have the primary Behn interface with the stay take everything as well. Yeah, so this is duct and session management, and it's going to keep track of things like what size or shape is my terminal, for instance, you know, like what's actually available to me here. The logging level stuff, which is also handled explicitly in in Behn, where you can toggle the logging level, then gets manifested here in Dill with being able to toggle things through verbosity. Let's see. One of the interesting things about Dill is that these events pass through Dill when you're booting the other events. So there's like when things hit the dawn stage inside of your ship, Dill is going to be the dispatcher for this. Ted, you could probably, well, okay, I think he just in time. I was going to ask him to comment on pack and meld passing through Dill there, but when he comes back, let's see if we can remember that, why those go there. All right, so let's do a life cycle. If we want to understand what's going on with Dill, like with a keystroke, let's go to our. Let me see if I can. Okay, there we go. I'm going to add folder to workspace, and I'm going to add there, and then it'll be easier to pull all these other things in. All right, so I want to go to var package var var.h. All right, and this is going to have a bunch of term functions here. This is going to give you an idea of like the kinds of things that Dill is set up to do in a public sense. So Behn only had one public function, and everything else was prefixed with a cab. It was intended to be private, local to the function that it's in. Dill, which is going to run everything through term.c, and that's what's going to be attached to CARU as our callback cycle. It actually supports a number of different things. So it has the spinner stuff. It has, you know, what's my window size or my change in window size. Has someone sent me an interrupt? What happens with that? Yeah, do logging, do cleanup on crash. Then there's a whole other set of functions in PTTY, which handles things for, are you on Darwin, which is Mac OS, or are you on Linux? And you get different behavior for the terminal behavior in those two cases. Term.io init is your main trigger. That's what actually gets registered with CARU when we in auto.c when we do that registration. All right, so what I want to look at is how a keystroke gets processed. Let me see if UV read start is explicitly, yeah, okay. All right, so what happens when a key is pressed? UV read start, this is what the libuv is, the event loop injector. So we're registering it here with a callback that will do this the first time we run it. But then any time that a keystroke hits the libuv event loop, it's going to go to cab term, cab read, cab cb. So this is our callback to actually process the character keystroke. All right, so let's go to that. All right, so this is connected to the UV stream, so it knows where everything is, it knows the values there. And it's going to pass things through to term suck. All right, this is your input processor. It's going to look at the size of the thing that you have in the buffer, everything that's going on, and the main thing that it will do is call suck care. The rest of this is error handling. Has something gone wrong? It's going to go to suck care. Suck care is going to have to make a decision between, is this something that is specific to the terminal emulator? Like, are you doing something that's just in your terminal emulator? So for instance, on my system, I have a meta key established where if I press the key and I type something like C caret, it makes a, what did it do there? Let's do like a slash. Oh, very interesting. I guess it's getting eaten because when it goes into Urbit, sorry, it's not a valid character. All right, so here's a UTF-8 character, /O. When I press my meta key, this is not actually transmitted to Urbit. Urbit has a meta, but I think when Urbit's meta is the alt key. This is handled by my terminal emulator. So this is not something that actually needs to pass through to Urbit because this is not resolved into a particular character yet, right? So I could do, there's a pound symbol. Like once that pound symbol is resolved by my meta key, by my terminal emulator into a character, then that character gets passed into the libuv buffer as a particular value and gets handled by Urbit. So suck care is deciding like, how do I, what do I do with this? Is this actually a thing that I need to pass into Urbit, or do I just skip on it and deal with this? Then that's going to go to term.io spit. Spit is the opposite because spit is going to input the buffer to Urbit, and then it's also going to update the screen because I typed character, right? Like there should be something that happens in this. So it's going to input the buffer in belt, and then this is going to go to term.io belt. And then finally in term.io belt, we're going to construct the ovum, which is our raw move, and deal with actually passing that value. All right, so this is kind of this circuitous route to get to that. So all of that was the processor in term.c before we get to Arvo. Now we have an ovum, we've injected it into Arvo. Now we can process Arvo, it's going to be a call. All right, questions about the runtime side of this? This is where I pointed out to Mopfil that He did a spit and a soak, and he could have done a spit and a suck, and it would have been a perfect match.
I could
Although
have.
that might have been confusing too,
It would
right?
have been very confusing.
Uh-oh. Looks like the kids have a half day today, so it might get loud in here in a second, but we will press forward nonetheless. All right, so let's go to, I guess we can just sort of talk through Arvo for a second. So call is going to take this ovum task and dispatch it on belt into Dill. All right, so then in Dill, there is a let's see, where is oh, sorry, I'm in sorry, this is an aqua handler. I'm in the wrong Dill. That's what's confusing. Let me find the right Dill. This afternoon, I'm talking about aqua, pyro, and test harness stuff on Urbit. So that's why I have all this aqua stuff open. Okay, so I'm looking for call here. All right. So AS is your per cause engine, right? Like a trigger has come in of some kind. So it's going to come in, going to get dispatched through the call arm here. So there's a call arm in the main interface, and it's just going to pass it through to the handler up here. All right, now at this point, we're going to dispatch it along belt. So we're going to send that keystroke verified as a Dill belt. So this was like the more color belt entries that we saw a moment ago. That's going to get passed into send. Send is responsible to dispatch it to the right session. Yeah, so send is going to send it to the right session as a Dill poke. And that goes through deal, which already knows which session it's in. And then that goes through pass. All right, and then what does pass do here? Wire note. Okay. So now Dill has processed everything. So where does this end up after Dill handles it? Like if I'm
Arvo?
seeing it here, where is it?
I mean, from here it goes to Arvo, right? And then to Bear,
Well,
or
back to Arvo, and then nope, not to there, to Gall. Hi. All right, so this will be a pass through to Gall. Because Deal, you see, Deal wraps it with a send G.
oh, I see. Yeah.
So now we've ended up in Gall, and then Gall decides what to do with this thing. Right. So if you've written a shoe app, now this goes into your command parser. And this is like the way that Dojo receives it in its command parser arm. Which is why if I do a keystroke, it is parsed immediately. And if I type something that's invalid, like, you know, I'm trying to do a capital A right now, this is going through there in Dill, but when it gets to Dojo's command parser arm, it doesn't have a way to parse it, so nothing happens. All right, so now we've seen the full life cycle on this. Okay, now output going the other way can actually happen 3 different ways. So input all comes in, Dill-based, terminal-based input all comes in this way. Output can actually run 3 ways. All right, so one way is that there's a slog. All right, so a slog means that it's a knock 11 hint ultimately. SIGPAM does this directly, or you can run it with a SIGGAR. There's a slog arm that does this. This is going to emit a slog hint to the runtime that the var will pick up via the knock 11. And then it goes through trace.c and puts it into a printf handler and outputs it directly. So there's actually a whole process where it ends up like jamming it, sending it to Newt, and then pushing it as a buffer to a stream into libuv, and then UV write actually produces this value. So even though like we say this, like we don't actually just printf it, we actually pass it through into libuv and process everything this way. In this case, output results in the fact that the layout handler, or sorry, that the terminal layout just changes, and it's not actually known about by Dill. So this is when you start getting, like if you have error messages or something and your output happens in a different order, and you get scrolling or whatever, and it's coming in different places. It's because there's 3 different ways to do it. If you slog, it's in a different event cycle than it is if it's coming from Dill. This is one reason why if you're producing Dill-based blitz, this is things like Snick, which is Palfin's snake game. You actually have to produce blitz directly, and you have to manage the terminal layout explicitly. And you don't want any slogs. You have to make sure people don't do any slogs in the middle of your nice clean screen, because otherwise it'll just print in the middle of your screen. And so if you go to, I don't think I have a copy of it here, libe2e, Enhanced Text User Interface, which is in the TUI Toys. I think TUI Toys is the name of the vein or branch of Urbit. Then you can see some examples of how that would be constructed if you're going to do it all as manual blitz. But it's kind of messy because you have to do explicit terminal management to do all of these things. And then the other way you can get output is term.c. The runtime manager itself builds these things. And so if we go back to term.c, if I still have that open somewhere, let's go to, there's term.c. I'm looking for show line. Yeah, so this prints at the cursor, but this is all done on the runtime side. And so if you were doing a different terminal handler like WebTerm, then it might make different decisions about how to handle these aspects of layout. So this is what actually maintains. So your Dojo prompt now, this was not always the case, but your Dojo prompt is always at the bottom of your terminal screen, and everything scrolls back up. That's maintained by term IT show line. That's a decision that's made here. Yeah, it calls through to restore line, which is what actually always enforces this input at the bottom of the screen. Yeah, you'll see that actually when we're doing output here through term.c, it's receiving it as a UTF-32, so a 4-byte character from Urbit, and then it's converting it on the fly to UTF-8 just by checking what my actual bits are, the leading bits of each character. It's kind of complicated. I mean, it's interesting, but it's kind of a complicated way of doing it. Let's see. I wanted to look at U3 term log init. Yeah, so this is registering an output pipe with libuv. So you have a way of knowing, like, you have an output buffer somewhere. And then this stuff passes through to whatever your specific system is doing for its local terminal stuff. Anyway. Okay. So that's the runtime side of basic Dill. Other things Dill does, but this is the main thing Dill does. Yeah, here's your color escape sequences that are going to get output to your buffer, for instance. All right. The other thing I want to look at is what's going on with Dojo, Hood, Helm, whatever, right? So Dojo. All right. So Dojo is the primary CLI, right? It's what you boot into. It's what you're dealing with anytime you work with this. App Dojo. It's big. Let's see. Let's find. Yeah. So as an agent, about 2,000 lines to do things, and it has its own internal handler for everything. All right. So it is I believe it's explicitly a shoe agent or Soul, maybe. Yeah, so it's going through Soul. Yeah, Dojo command. Anyway, all right. So it's doing three things for you. Let's go back to my text here. All right. So Dojo does three things. It has a Hoon parser. It has special syntax to look things up. So these are bar, hep, less, so that you can identify a generator, or col for a poke, pam for a mark, tar for a redirect, tis for a variable definition. Gosh, what else is there anything else that's a Dojo specific syntax? I can't think of another one.
Isn't dot is another one, right? That's how you like make fills and stuff. I don't remember what exactly that does, but
Oh yeah, there is something with that. Yeah. Anyway, so basically these are all just special cased, less looks in gen, hep looks in ted. Bar is actually syntax for hood bar, like by itself, it's syntax for hood bar generator, like whatever the generator is. There is a zap, but the zap is like if I'm referring to a generator on a particular desk, then I do it that way, right? So these are all just commands to Dojo to redirect these particular pieces here. And then the other thing you have is all the hood stuff, which is all the bar stuff. All right. All right. So hood is the system app. And it's going to, so it handles, bar install, bar pass, bar commit. All these things are going through hood, but then hood has to decide what to do with it. And so hood has a few helper pieces that are connected to it. All right. Helm is your interface to the kernel, essentially. Bar verb, some of the veins work through it. So like bar moon generates a vein. The reason that this is all set up through hood is that you need to be able to subscribe for returns. In many cases, these are not necessarily raw scries, right? Like bar moon is not a raw scry. Like what does bar moon do? Let's go to gen hood moon. All right, so it's dispatching things to where's jail? Okay, so okay, whatever it's doing to jail, it's actually wrapped in something further on down because it has these other pieces. So anyway, but these are passes, right? Like these aren't scries, these are passes. So you have to be able to receive a gift or do something with it to be able to do this. Like a regular generator can't pass a card, can't pass a move, can't do anything like that. So that's what Helm is designed for. Drum is the CLI session manager. All right, so this is why when you used to crash a scry, you'd get a drum error of some kind, like that's what would crash and go away. And then Kiln is a file system. So this is it's the clay wrapper. This is the Dill wrapper, or this is other veins, essentially, is what that wraps down. The call web of these gets rather complicated. And so for instance, if we go into link, all right, so remember what bar link does is it connects a command line session command parser and on command of a shoe agent to Dojo, so you can cycle through and you can run things explicitly. So if we actually run bar link, what it's doing is it's producing a say. So it has a cage inside of it that's a drum link, which is a pair of drum session and parsing out these arguments. So to figure this out, then we need to go to, so this is going to get run in app hood because it's a hood operator, and via drum link. So let's go to app hood and look for drum. I think these may just go as a drum poke. Okay, it comes as a poke drum. There's a poke helm, there's a poke kiln. All right, so if we go to poke drum, as an aside, Little Wolfer has been working on a VS Code plugin that will actually let you like control click through on these, so you won't actually have to like hunt from file to file to file. Let's see, it's gonna be really nice to have that.
That might get me to switch to VS Code. Holy crap.
Yeah, it'll be really nice for it to like just know about these things. Hood drum. All right, so there's drum. We're looking for, anyway, okay, so sorry, poke. So poke drum in app hood went to a poke drum arm that called poke inside of drum. And inside of this, then it's going to find poke link is going to be what it's dispatched to, which calls a bet on SE link. There's that pattern again. And ultimately we end up by putting something in our eel. Well, what's our eel? What's an eel? Let's go look up an eel. This one's funny. I like this one. An eel is a set of gills. Basically, your gills are how Gall manages its sessions from its side. So an eel is a set of gills. And anyway, so that's what it looks like to bar link something. You're registering this connection endpoint with drum into Gall all the way back into the actual set of connectors that Hood is aware of here. It's kind of a like circuitous route to actually end up at that point. Yeah. Yeah, okay. So let's see. Yeah, I think that's it for Dill. We looked at the terminal side, we looked at the user space side. What questions do you have?
I have one quick one.
Yep.
Which is that things are kind of this circuitous. It seems like just because of the whole Gall monitoring capabilities, right? Like normally if you're just outputting to the terminal and you weren't considering anything that these Gall agents were doing. I mean, I guess I don't even know what that would really look like because Dojo was a Gall agent, right? So there'd have to be some weird, like if you're just blitting things to the screen using Dill and handling it via that way, like,
Yeah.
well, it's unclear how that would be like, where that state would be managed and so forth. I guess would be its own sort of like blessed agent thing, but it's wrapped into Gall itself, like as an agent that has its own state and monitoring and so forth. And that's kind of why it seems there's all these routes to be able to say, like, we have to go back to Gall to be able to monitor make sure that the input is proper, right? Like that there's no syntax errors and that sort of thing.
Okay, what's the question in short form?
Yeah, the short form is like we have to go through all this circuitous route because Gall's involved. Is that correct?
Well, you have to go through the circuitous route. Okay, I mean, so you can imagine an Urbit that's much simpler and had a dojo, but didn't allow linking.
Mm-hmm.
And if you want to interact with an agent, you just have to like explicitly tell dojo to poke that agent.
Mm-hmm.
Right. That world, or you know, and it only has like one Dill session. There aren't multiple Dill sessions.
Mm-hmm.
That world's a lot more straightforward because if you wanted to do something, you wouldn't have to like link and keep the state in hood and pass through to drum and poke it in 3 different places and keep this set and all this other stuff. You would just have to dispatch the move from dojo Gall to the agents on poke arm and Gall.
Mm-hmm.
Right, like there would be no other pieces with it. So I think arguably a lot of this kind of complexity is coming because you want to have things like session managers and multiple kinds of operations present to you.
Mm-hmm.
Right, like you actually you know, as soon as you add sessions to Dill, as soon as you add sessions to your terminal handler, well, now you have to have plumbing that can take care of dispatching to sessions. And that adds complexity.
Right.
Right. Like there has to be a call wrapper that does that dispatch as soon as you do that. You can't get around it if you're going to have sessions.
And there's also the whole soul and shoe stuff, right? Where like a session could be managed or mediated by a call agent.
Right.
Which has its own, like, what's the word? Autocomplete, right? You can tab and see like what options are available to you and this sort of thing. And that kind of has to be mediated somehow. And it seems like this is kind of these guilds, a set of guilds that we were just looking at. This is kind of the stuff that looks like manages that in some way.
Yeah.
Okay. And one other, if I may, is on the ways, like you were talking earlier about the ways of input versus the ways of output.
Mm-hmm.
Is there any, like, is it possible or is there any desire to have it just be like one way of output, or what are we just kind of stuck with as things are architected, having these 3 different ways of outputting, via slogs, blitz, or term.c?
Well, I mean, the term.c, and I mean, there's also like direct printfs, which I'm leaving out of this. I mean, you want your runtime to have a level at least for debugging and error printfs that's outside of Arvo. Right? Arvo crashes, or you know, something happens and you crash, you at least want your runtime to be able to manually put things out.
Right. If something weird happens, go ahead.
I mean, I guess you could imagine a world where you unify slogs through blitz, or like every time a slog occurs, it gets rerouted through a blit. I don't really know what the value of that, like I don't know what the value proposition of that would look like.
Yeah, I guess the one thing you were talking about earlier was when you have both of these, like if you're doing blitz, like you can't have any slogs or else they'll mess everything up, right?
Right, because slogs don't go through Dill, and so Dill doesn't know about your terminal layout. So if it's drawing things, it can mess up a drawing.
Right. But I mean, if you're drawing things pretty carefully, like it seems like any unusual prints that you're not expecting can mess it up. So I don't know if there's a huge improvement there by unifying them. And I mean, it's a hint, right? So this is ultimately handled by Bear. Or whatever runtime you're running. Aries, I guess, could also be what's handling this log ultimately.
Well, I mean, I wonder if maybe something you could think about doing there is have some sort of way of signaling the runtime to turn slogs off while you're doing pure blit rendering.
Mm-hmm. That's interesting.
Kind of like a zap call zap dot pair that
Mhm.
turn slogs off while I'm running this CLI game.
Hmm.
Queue them somewhere, but don't dump them to the buffer.
Hmm.
Right now that doesn't happen, but you could imagine that being possible.
Yeah, absolutely.
That's all
Yeah,
hints anyway.
And that makes sense kind of why they have to be different. I mean, term.c is fundamentally like these are things that the runtime runs. Like this is just like the runtime might have to output something that's separate from Arvo and so forth. Arvo kind of goes through Dill Blitz, and then slogs are hints to the compiler that might just output something. So, or excuse me, hints to the runtime. But anyway, yeah, okay, makes sense. Thank you.
Ted, I think we had a couple of questions we wanted to run by you coming out of this. If you're there.
Yeah, go for it.
One of them is, why does Dill have the pack and meld in it?
Mm.
Let me go back to let me find Dill here.
A lot of just
sort
sort of like system lifecycle kind of stuff lives in Dill.
yeah, pack and
It's
meld.
it's used as a kind of, among other things, as a kind of catch-all, or like, all right, there's some kind of miscellaneous system task where you want some vein to handle. Which vein should that be?
Mhm.
I would note that those are not particularly well considered choices. I think it's like partly historical. If somebody has a better idea for like how
We
those
need
tasks should be done, then feel free to like write that up as a UIP, and we'll want to merge that. I
M
think
for
like,
meta is a great is the next letter.
you mean for a vein?
Yeah, just have a vein that
It's
just handles all the.
That is not a
Well, it's
famous
gotta be some-
person.
Yeah, it's got to be somebody's name who's
Oh,
worthy of a kernel module being named after him forever. There are a couple of exceptions there that we need to fix. Actually, it might just be Iris.
Well, I guess the
Lick
related
is named
question.
after Lick is named after Richard Licklider, who was the ARPANET guy. He went by Lick. That was his nickname.
Why we named it that.
Yeah. But I don't think I would make a new vein just for handling lifecycle stuff. It just seems a little heavyweight. Dill, it also might just be totally fine to have this stuff in Dill. You do have to put it somewhere. But it might be worth thinking about putting it in con at some point, because it's kind of a control plane related thing, right?
Yeah.
So I don't know. Yeah, but like in general, that stuff has sort of grown and evolved over a decade,
Mhm.
and it wouldn't surprise me if somebody taking a close look at it and doing some top-down organization could clean it up. It's not a high priority for us at the moment because it's not causing us any problems that I'm aware of. But that doesn't mean we shouldn't do it at some point. I'd certainly be happy to see a contribution on that and take a look.
The question, which is probably related in the answer, is about why the boot process stuff passes through the vein wake up stuff passes through Dill.
Just the boot task or the
Well, like here,
init task?
the initial duct distribution. Like it boots jail. Jail is booted from Dill, for instance.
Yeah, again, like this is just how it works. You can build this a lot of different ways.
Yeah,
there
that's
may be a
fine.
way that's better. And I mean, I would say that stuff's not that bad in the sense that, well, first of all, it works. As far as I'm aware, it's not that fragile. There may be some ordering dependencies there that are a little subtle. But also, Yeah, so like like you can what I wouldn't want to have a kind of like big system, that sort of manages boot, right? And does some kind of has some sort of abstractions, and then you like make plugins using the abstractions, and then right, like I would rather not have any of that. Because the thing is there are a finite number of veins, and the boot sequence is not that complex. And so if we can avoid having a big clunky piece of machinery, that's good. Yeah, one nice thing about Dill here is it just kind of hard codes. Like if you look at the clay initialization here, no, like in Dill, actually might do it through Hood. I'm trying to remember, but there's like a what's a writ that's going to be in response to into, I think. Search for into.
Yeah, it might be in Hood.
There's no into.
There's no into in Dill.
Yeah, there's a name for the Hood app here. Okay, it's app. I see it. So like, what do we send to app here?
Oh, right here.
Yeah, is that it though? I thought there was like I thought Dill had like a piece of its state that says like this is the initial app that we're going to ask to do stuff. Can we look at the Dill state?
Mm,
Might be RAM. No, that's a session name.
well, it's a console program.
So maybe it's the app. I don't know. But in any case, that's not what I was thinking. Maybe Dill doesn't have this in its state anymore. Where is that the only mention of Hood? It talks to Hood in a few different places.
So there's a
Okay, it's just hard coded.
configure. No, here we go. If you get an init task, you set up Hood and Clay. But it's hard
And
coded.
this does and look at line 293 into as duck. Like what's the as for?
As is the per cause engine in
Okay,
as
so
is
Dill,
this door. This door we're in.
are you
in
sure
Dill.
it's this door, or is this the outer call, and then as is the inner one? Yeah, okay, so yeah, so as is like the inner helper core, right?
Yeah, I'm seeing what we're inside of here.
So
Okay,
what is
we're in
into
call. We're in
arm?
call. We're in the interface vein or the interface core.
Right, so the interface core calls into the helper core, as is very common, right? And so then as is the helper core. So what's the into arm? Is within the as core.
Pass Clay warp. Yeah, so pass a warp to Clay.
Well, this is interesting actually because it's not sending into to Clay, which is sort of what I would assume it is. An into is a write to Clay that like tells it to do some file or to like make a commit. But I think what we're doing here is we're doing a warp, which is a read first, and then we're going to get a response to this into we're going to get a response to the warp, which is going to be a writ. So right, a writ is a response to a warp. Yeah, I think that's right. So search for writ again. That was in takes. Right. So this is async, right? So we're going to get a writ. Then we call a init. So what does init do? Now we pass a merge. Okay, yeah. So here's what I was trying to get at. Is that like, I just remembered that, I didn't remember exactly how it worked, but I knew that there are a couple of kind of like pretty hard coded things that Dill does to initialize Clay, right? And one is here that we merge base into kids. I'll just select the video. All right, now it's back. Right, so like we merge base into kids here. Search for merg, M-E-R-G, because I want to see if there's anything ACK on this causes anything else.
It was in the
Right, like if
notes,
we
it knows about it. Yeah, that's it. It's those places.
That's it.
It
Okay.
registers it as a note and then it has it here in the init.
Okay, and then is there? I guess I feel like there's going to be somewhere where you get a. Yeah, mirror. Okay, so I think mirror is the ACK on the merge. If I remember right, like Clay actually gives a response once it finishes the merge. So I think this is handling that response. Excuse me. Yeah, right. So
Yeah.
here's where in take, and we're saying if we get a mirror, then call the mirror on. Right, fire the mirror on.
And I guess
so
it's because
let's
of
look at.
Behn, because it can be a drift.
That's right. Yeah. Yeah, because Clay may not do it. It may not give you the response immediately. It may drift the response in a separate event. So let's look at mirror. Yeah. So then this does some other stuff with Clay, right? It sets the base desk to live, which says turn on all the apps, like turn on all the agents in base. Then show desk kids, which I think sets the kids desk for public, so that other ships can read the kids desk, right? And this is how OTAs work for the kernel, right? You don't download some ship's base desk, that's usually private. Instead, you download their kids desk and you merge that into your own base desk. And the reason I do that is that sometimes we want to do a hotfix on like a Galaxy, but we don't want that to propagate throughout the whole network, right? So we want the base desk, which is what that Galaxy is actually running. We want that to be able to be different from the kids desk. So typically, you take the base desk and you keep the kids desk synced to that, but you can desync those if you want and manually just run something internally without telling all of your children to also run them. So in any case, we publicize the kids desk here. And we do some open thing. I'm not sure what that's about. But like what's nice about this is it's all just hard coded right here. There is no abstraction, right? There's no like work queue or anything like that, right? There's no like explicit declarative system for dependencies, or you can imagine that like some systems have stuff like that. Right, and you could imagine building tons of machinery here, but we don't actually need it, and so just hard coding it is actually really nice. So that's why I wanted to show you guys this. But even if we cleaned up the way it goes, where like when Dill, because right now this is Dill handling it, maybe it shouldn't be Dill, maybe it should be Con. I don't know, but like, if there is some piece of this that is deemed to be unclean, and we want to like sort of rectify it, it would be nice to rectify it in such a way that maintains this property being very low level and direct instead of being abstracted out.
So just as a quick review of Ted, what you just explained is that like there's no abstraction layer, like the system I'm using OpenRC or like run it, or I guess systemd is the most complete of these examples, you could say. Here instead we just have a Behn handling some of these initializations that need to occur. And maybe it doesn't matter which Behn that it is, but because the set of Behns is fairly limited, like maybe it doesn't make sense to have something that's so thorough in how it sets up dependencies and all this other stuff. Maybe we could just have like, here's a set of things that needs to be initialized. Maybe there'll be a dozen, maybe 2 dozen of these things, and so it won't be super complicated. So therefore, just having it be direct is simpler. Is that
exactly? Yes, I was actually thinking of systemd as a contrast when I was saying it.
Yeah, systemd is the most like, that's like the crazy end of where everything is managed by the init system. There are like simpler ones like run it or OpenRC, and like entire Linux distributions have forked over that particular decision. But like even still, you have to set up your dependencies, and those can get pretty complicated. But since we only have a couple of these, not very many, maybe just do it directly instead. Don't need an entire abstraction for that.
Right. And hopefully we never will. We'll see. But my guess is we won.
All right. I think that wraps it, unless there are other questions. All right, we've done the whole Odyssey here.